Hi, I'll go over lab 1 of ECE 285, which is regarding components, Ohm's law, and Kirchhoff's law. So for the first part, you're measuring the resistance of 15 10K resistors. So what you would do is you would switch your multimeter. Your multimeter might not have as many features as this one, but you would go to the resistance section. And so you would pick the value that's higher than your resistance that you're trying to measure. So for instance, this resistor right here is about 7K, like I believe it's 6.8. So I can't use my 400 because that's the max it can measure. So I'll go to my 40K and measure with that. So I'll just get my two probes and I'll just put it across the component. And then you see it's 6.7, and I believe it was 6.7. So yeah, that makes sense, and it's within its tolerance. And then now you measure 14 more 10K resistors. And that's how to do part 1. So for part 2, you are testing out Ohm's law with the LED. So for this, you definitely need your multimeter. So what I'm going to do is I'm going to take these out and then connect these cables that have banana clips attached to them, and then just connect it to a port on my breadboard, and then have another one come out and connect to my ground. So this is where current's going to come in. So current's going to come in, and I'm going to put it into my milliamp portion, and then switch my multimeter to measure current before it starts yelling at me. And then so what's happening is if I were to supply voltage at this node right here, current's going to flow through this cable, the black cable, into the red, go through this, and then come out through this cable right here. Sorry for all the cables. So this cable that I'm holding up right now, all are attached. So it will come and meet at this node right here and flow into the resistor. So let me connect that. Okay. And then now I'm going to need power. So this is where I'm going to use my M2K. So it's on the side. So let's see. So I'm going to get my red cable, which is going to be my power, and connect it to the initial node where the power supply, where my first pin of the ammeter is, and then connect my ground to my circuit. And then I want to measure the voltage as well. So what I'm going to do is I'm going to measure the voltage of the resistor. So I'm going to make channel 1 measuring the voltage of my resistor. So I'm going to grab my orange cable with this, that is the solid orange cable, not a white line, and then connect that on one end of my resistor, the side that's facing the power source. And then I'm going to grab the orange cable with the white line and connect it on the other side of that resistor, the node where the resistor and LED meet. And then I'm going to get my channel 2 wires, the solid cable, the solid colored cable without the white line, is going to be connected at that same node where that resistor and LED meet with the orange with a white line cable. And then the blue cable with the white line is going to be connected at ground. Cool. So now let's clear things up so that way we can see everything. So this resistance right here is supposed to be a 1K or a 10K. So you do the experiment where you vary the input voltage from 2 to 10. So actually you should not be using a ground cable, use the white cable from the M2K. Cool. And just plug in your M2K. Cool. There's a lot of wires, so just ignore that. So yeah, so you're going to vary the input voltage from 2 to 10 if you are using the 82 or the M2K. And then you repeat the experiment twice once more using a 10K. But you're changing the voltage in increments of 2. So I'll just open up Scopy. And once I do, I'm going to just click on the M2K that pops up, click connect, give it a moment for it to connect and calibrate. Okay, perfect. So now I'm going to go under power supply. And so now that I'm using both my positive voltage and my negative voltage, that means that the sum, the absolute value of the sum of both of these sources must equal to the supply voltage I want. So let's say I want to output 2. volts. So if I apply 2 to the positive voltage and 0 to the negative, I'll get 2. If I apply 1 volt to the positive and -1 to the negative voltage, I'll get 2. So if I do 0 and -2, I'll still get 2. So you would have to do it in that way. So I'm just going to do 1 and 1. Oh, gotta add it. There we go. 1 and 1. So as I do this, you'll see the current for the LED go up. So if I turn off this light, you could possibly see the LED start to flicker ever so slightly. But as I increase this voltage, so let's say I increase it to here, let me do this. Let me move this to my separate monitor. And then you should be able to see this. So right now I'm outputting, let me turn this off. So there's 1 volt going in. So it's slowly increasing. As I increase the voltage, the brightness increases. You see that. But as I decrease the voltage, the voltage, or sorry, the brightness of the LED diminishes. So that's what you're supposed to observe. And as you vary the voltage, or not necessarily voltage, sorry, the voltage inputted, the current will also somewhat fluctuate. So here's the, I'm going to increase the voltage now. You could see how the current increases when I do this. There you go. So that's what's supposed to happen. And so for experiment 3, you have this interesting looking combination of resistors, and you want to measure the voltage and current through all these components. So what I'll do is I'll just measure the current of R1 and the voltage drop of R2 and 3. So that way you kind of have an idea what you should expect, but I'm going to change my resistance so you don't necessarily, you can't really copy what I'm doing and translate it into the lab. So give me a moment to wire that up. Okay, so I have a circuit that looks similar to this in configuration, but the resistance values are different. So my R2 is replaced with a 100 kilo ohm resistor, and R3 is replaced with 10 kilo ohms. So essentially it's 10 kilo ohms in series with another 10 kilo ohms. So if you do the parallel combination of 100 kilo ohms and 10 kilo ohms, you get roughly 10K. So now if I supply 10 volts, you should expect about 10 volts divided by 20 kilo ohms, which is some number, which can't think of right now. Give me a second. So the current that should be going through the circuit is about half amp. So I1 should be about half. So when I do send in 10 volts, I get something else because I probably did my math wrong. But let's just measure voltage drops. So voltmeter, I'll just go under voltmeter and then click run for both. If they're connected properly, you should be measuring about half a volt for each. And that could be because I don't have everything plugged in. There we go. My connection was loose. So let me redo this. Now this makes more sense. More beautiful. So you see how that's half an amp roughly, but then if you look at the measurements, so channel 1 is measuring that 10K, that pure 10K ohm resistor. You'll see about 5, and then the R2, the combination of R2 and R3 with the 10 and 100K is going to be slightly less than 10K. So that's why there's more voltage drop off the R1. But when you do measure the current, you see how it matches, how it's supposed to. So that's how you essentially do lab 1 for ECE 285. Good luck.